ones who know where they come from. The ones who know what they want. The ones who deliver. We are the ones.
Today I'm going to be telling to you about an interesting development in our product line regarding coaxial monitoring products. We have been offering 8351 on the market quite successfully for some time, and it has become clear to us that we would need to have more loudspeakers, monitors in the same format, same coaxial design, but maybe slightly different, slightly smaller in size, more compact, able to go into smaller venues and rooms. We are now coming out with two new products. They are called 8331 and 8341, and this creates a family of three coaxial monitoring products called the Ones. So the family is going to look like this. On the right side there you see the 8331. In the middle you see 8341, and in the left side you see the 8351 that has been on the market for some time. And you notice that there's a great similarity in terms of design. We have the same coaxial driver approach. The coaxial driver is in the middle of a directivity control waveguide, and then we have a dual woofer system on both sides of the coaxial driver, and the dual woofer system not only creates a higher output capacity, but it also creates controlled directivity down to very low frequencies. And this combination of four drivers in a three-way design creates a unique way of reproducing audio and creating more accurate, more precise monitoring products. But let's go through some of the problems that we have been able to solve with these new designs. The first problem that coaxial products solve is the problem of what happens at the crossover frequency of any monitoring loudspeaker. If you have the traditional monitoring loudspeaker and you're moving off the acoustical design axis, then the timing between the two drivers playing simultaneously at the crossover frequency changes. And this timing change creates phase mismatch, and that creates a situation where the frequency response at off-axis locations is no longer flat. This is a quite audible coloration. Now, where this coloration happens depends on how the monitor is installed in the room. In normal typical designs, this usually happens when you're moving up or down relative to the acoustical axis. If you turn your monitor 90 degrees, for example, to place it on the meter bridge, then this coloration may actually happen when you are moving left and right relative to the acoustical axis. What we are doing in the Ones products is we are using the coaxial driver and then an acoustically coaxial woofer driver system to correct for this problem. You see the driver layout here. You see the coaxial driver, the tweeter mid-range in the middle there, and then below and above we have the two woofers, creating a directive woofer system. Now all of these three drivers driver systems are acoustically on the same axis. So when you move off axis, left, right, up or down, then the timing, relative timing between the drivers doesn't change, and you experience flat frequency response even if you're moving off axis. Now, even if you were not planning to move off axis relative to your monitor, this still has significance, because the loudspeaker is radiating out audio into all directions, and this means that the fact that we are able to produce a flat frequency response is going to create a cleaner reverberant field in the room as well. Then there's another problem that we are able to solve with the coaxial design, and that is the problem of the minimum listening distance. If you have the conventional design with the woofer, mid-range and tweeter located at different locations on the front baffle of the monitor, then if you start moving very close to the monitor, then the relative directions of the drivers start changing, and this creates a situation where it's no longer possible to produce a flat frequency response to the listener, and you start having coloration problems. Now, the traditional solution for this is to define the minimum listening distance. So this simply means that you are far away, enough far away from the loudspeaker, so that the relative timing, the relative angles from the different drivers are kind of okay for the application, and you can have a frequency response that is flat enough for the purpose. Now, when you have the design that we have in the ones with the coaxial characteristic, then the geometry between the different drivers doesn't change, and all the drivers are on the same acoustical axis. When you have all the drivers on the same acoustical axis, this means that you actually can be very far or very close to the monitor, and you experience the same flat frequency response. So this means that we are able to create monitoring systems that give you a great degree of freedom in terms of the distance that you are located relative to the monitor. Now, once we have this, we can exploit it to our benefit. One of the ways to exploit this is to control the amount of room reverberant coloration that you have in your monitoring audio. If you are far away from the monitor, then the direct sound relative to the sound that you are hearing from the room is dominated by the room reverberation, and your frequency response may not be extremely flat, but with this kind of monitor design that is coaxial, you actually have the freedom, the choice of moving closer to the monitor, and this increases the level of the direct sound while the reverberant sound level remains about the same. So the ratio of the direct sound relative to the reverberant sound improves. And you can, with this simple method, you can control the cleanness of the audio reproduced by your monitor. So the acoustically coaxial monitors offer you this possibility. And since we have optimized this design very carefully, you can actually be really close to any of the ones monitors without any problems. We have tested this to distances less than 0.4 meters, about that much of distance, and you can enjoy the same high quality reproduction at this short distance from the monitor as well. So the choice is yours. You can listen to these monitors at any distance. You can experience the same high quality reproduction at all distances. But let me go into explaining a little bit more about the construction of these monitors. There are certain features, certain design characteristics that we have built into these monitors. First of all, we have the coaxial driver with a design that doesn't have any acoustical discontinuities. When we can achieve this, it means that we can actually eliminate the problems that conventional coaxial driver designs have in terms of having gaps for movement of the drivers, and these gaps can cause diffraction that can color audio. We don't have these. The front baffle of our coaxial driver is acoustically continuous surface, and it doesn't stop there. Basically, the whole front face of the one's monitor has been designed as a controlled acoustical surface, and I'll come back to that in a moment. The two woofers have been acoustically concealed. This means that for high frequencies and mid-range frequencies, the high frequencies see an acoustically continuous surface, and the woofers are radiating through these two openings that you see at the top and bottom of this enclosure. And even if they are able to very efficiently radiate low frequencies, in terms of high frequencies they are invisible, and that's very important because it means that we can actually create a monitor that has a very flat frequency response, not only on axis but also off axis, once we have this kind of design. Now you also notice that the enclosure shape has rounded corners. These have been carefully optimized to minimize diffraction that the monitor enclosure is creating. So we have an acoustical design here that is radiating very flat frequency response and has an optimized enclosure in terms of the cleanness of audio. The size of the DCW, the directivity control waveguide, has been maximized because we are able to hide the two woofers, and actually the surface area of this directivity control waveguide here is larger than for many main monitor systems that you can find on the market today. And this means that we really have very good control of directivity down to low frequencies for this design. We also have very rich signal processing features, and in order to understand those you have to look in the backside of the product. These three products support the smart monitoring concept. This means that we have some freely adjustable resources inside the monitors. We have a software-based measurement system that can take a measurement of the monitors in your space, and then we can calculate the compensations for any acoustical influence that your room may be causing on the audio. The result of doing this is cleaner audio, the more systematic monitoring, easier system to work with. We support an analog input, an AS-EBU input, and AS-EBU input with supporting all the word lengths and sample rates that you use in professional audio. You notice that we also have some manual controls in the backside of the product. If you are in a situation where you cannot use the computer optimization for some reason, then you still have the possibility of using the regular manual controls for improving the quality of audio in the room location. Okay, let's take another look at some of the inputs and outputs we have here on these systems. On the right side here you see 8331, on the left side you see 8341. You notice that 8331 has only one input, and that one input is very special. It can adapt automatically and become an analog input or an AS-EBU digital input according to the signal that you are feeding into it. The 8341 has two separate inputs. It has a separate analog input, separate AS-EBU input. Now this is very important, and it's the same kind of design we also have in 8351. It gives you some additional degrees of freedom with the GLM, Genelec loudspeaker manager software. You have the possibility of controlling which input you are using, and you can have both inputs connected at all times. This may be very handy and useful in some situations. The mains voltage, the mains power input is interesting. It's a wide voltage range input. So basically this means that we have the possibility of providing full power everywhere globally. So wherever you plug these products into the wall outlet, they will always be able to give you maximum power output, and they will be able to adapt to any mains voltage that you may have. Okay, let's take a look in the inside of these products. If we explode these products, you can see some of the main components that we have inside there. You can see the two woofers, you can see the mid-range tweeter coaxial driver units, you can also see the bass reflex port structure, and you can see the electronic boards. But let's look at the acoustical design details of this enclosure. If we cut through this enclosure and we look at the shape, the profile that we have in the front of the enclosure, we can notice that this coaxial tweeter mid-range driver integrates well into the enclosure, and actually the mid-range driver surface creates a continuous acoustical shape in the front of the enclosure with the front enclosure part, so that we can really extend a directivity control waveguide over the whole front of the enclosure here. You can also see that we have used all the space available in the front baffle of this product for creating audio. Really the two woofers, they are hidden, but we really use all the real estate in the front baffle for the woofers. So there's no space wasted in this design. Okay, let's look at some of the features and specifications for these three products. If we just look at the overall acoustic specifications here, you notice that we have three designs where basically the low corner frequency, so how much extension in the bass frequencies you have, varies slightly depending on the product. So for 8331 we go down to 45 Hz approximately at -6 dB point. For 8341 we go to 38 Hz, and for 8351 we go to 32 Hz. But all of these products actually cover not only the whole audio band, but they also extend to ultrasonic frequencies, with the output extending to about 40 kHz for all of these products. So these are truly high resolution monitoring devices in all senses of the word. And the frequency response is highly controlled. The ±1.5 dB window for very accurate control of the on-axis response covers most of the audio band. You can also see the crossover frequencies there. You can see the short-term and long-term maximum sound pressure levels that these devices can create in anechoic conditions at 1 meter. The dimensions of these new products are very interesting, because the 8331, 8341 are very compact. Yet they have with very high output capacity. So this creates some interesting possibilities. I believe these are going to be really important in the future to shape the way people are monitoring audio, the way people are using monitoring loudspeakers. 8331, I believe, is the smallest true three-way design on the market at the moment, but it's certainly not small in terms of performance. And this is very, very interesting. We also have some accessories to support installing these in the walls, in the ceilings, on your working surface. So if you want or need some particular type of installation, please contact us and we will be able to tell you more. And we really have a very strong set of tools inside the monitors to adjust the frequency response according to the space, the room, the installation location where you put these devices. These are smart active monitoring devices, and we can adjust them into your space by using the Genelec loudspeaker manager software. This system not only compensates for any colorations that the room would cause on audio, but also, as it happens in many cases, the exact distances of your loudspeakers may not be precisely the same for all monitors, particularly in a multi channel system, a 3D audio system, and this smart system can compensate for that. Also, we measure the levels of all the monitors at the listening position, and we can compensate for any level differences that there may be. We can also synchronize with any video system. Now, the calculation that the computer software is doing after it has acquired the acoustical response in the room can happen either locally or it can happen in a cloud-based system. With the market introduction of the ONCE, we are also bringing to the market a new version of the GLM, Genelec Loudspeaker Manager software, that is able to offer calculation in a cloud computer. Now, this has certain benefits. One of the benefits of doing things this way is that you have a high performance computer doing the calculations in a very efficient way. Then you have the possibility of always having the newest methods and algorithms in use. So we are able to support our customers better by offering this kind of cloud-based computation service. We may also be able to offer specific consultation for our customers through this kind of cloud facility, and we are looking into that very hard at the moment. Let's look at some measurements that we have taken on the acoustical performance of these three products. If you look at the impulse response, you can see the impulse responses from all of these three different products at the top row here. And the delay from the input to the monitor to the acoustical output from the monitor is depicted on the bottom row here. And you notice that the delay is relatively short. It's only 3 to 4 milliseconds for all of these products. And it's also about the same for all frequencies, down to very low bass frequencies where the delay through the system begins to increase. This means that the reproduction of waveforms is very accurate with these products. If we look at the traditional frequency responses, here you have an overview of those. You notice that we have highly controlled on-axis frequency response. That's the thicker line, and then you see a couple of thinner lines at the top row here, showing you the frequency response at different angles, horizontally going off axis with the products. And the bottom row here shows you some detail on the ultrasonic frequency response of these products, and you see that all of these really are high resolution devices. They go to well over 30 kilohertz in the output bandwidth. I said that these products have very low delay, and that they are delaying all frequencies approximately the same amount of time. I have some more details about that over here. Here you see measurements on 8331 and 8341 in high resolution frequency analysis. And you notice that on the vertical axis you have the frequency from 1 kilohertz upwards to about 40 kilohertz, and really this is a way of proving that we actually have very constant delay through the system. Another interesting measurement would be the directivity, and here are measurements of the vertical and horizontal directivities for these systems from 8331 on the right to 8341 in the middle and 8351 in the left side. And you notice that we have very systematic and good control of directivity down to relatively low frequencies. So all of these products can control directivity well down to 500, 400 Hertz. And this kind of performance is something that you would normally never see in the traditional monitor design, because in the traditional monitor you would have the woofer, the mid-range, the tweeter at different locations in the front baffle. So at least on one of these axes, one of these orientations, you would see very different type of directivity characteristic. This kind of directivity characteristic is very close to ideal in terms of audio reproduction. This also means that you can use these products in any orientation. They can be placed vertical, they can be placed horizontal, they can be placed anywhere relative to the listener without any problem, because they are radiating audio in a highly controlled fashion. Okay, let's make a small summary of the benefits, the novelties of these new products. We have a point source radiator with controlled directivity characteristics, able to create very accurate imaging of the sound stage. These products are extremely compact, but they are extremely compact without compromising the performance of the products. I would say they have best of on the market directivity control. This means that you can have cleaner audio in acoustically challenging spaces, and this is very important for all of us. You have good control of the directivity, and you can use these products both in horizontal and vertical orientations without any problems. You really don't have a significant off-axis coloration. You have the benefits of the multi-way design, the three-way design, with each of the drivers reproducing a narrower band of frequencies. This means that these products have lower distortion, they are more linear than conventional monitor designs. This means that you can have a more analytical monitoring device at your in your use. They have constant delay, low diffraction design. This means that when you move off axis, your audio remains clean. You have the possibility of deciding how near or how far you are located relative to these monitors, because these are coaxial designs, so they enable you to choose the listening distance. First and foremost, these have been optimized and built and designed for a very long lifetime. And this kind of green value is very important to Genelec, and we really have gone into a lot of trouble to make sure that these products have a long lifetime of reliable operation for you.
So this is a presentation on the ONES, the new coaxial monitors from Genelec, from an applications and from like a sense point of view, why they're good, why we like listening to them. So these are the topics that we'll be going through. I'll start about the imaging issues, localization, and how we are hearing as humans. We have two different systems that we're actually using when we are localizing. And first of all, from what we would call vertical localization, we are using monaural cues. We're using both ears, but we are not using any difference between the ears, because when we're concentrating on up and down, then we have more or less the same intensity in both ears. What we're using instead then is spectral cues, and very small spectral cues. So for instance, if the high frequency content changes when we're looking upwards or downwards, that's the main component we're using. So that is very true also for head movements, and we're using constantly head movements to have good precision in our localization here. Then we're also using a different system in the horizontal plane. Here we're using binaural hearing much more, and here we're using two principles. We're using first of all, for high frequencies, we're using interaural level difference. That's where the head-related transfer functions come into play. So that's mainly above 1 kilohertz. But for lower frequencies, humans also have a secondary method. So in this case, we're using interaural time differences. So we can illustrate it this way, where it's now the time of arrival at the 2 ears we're using for very low frequency. So we have a phase-locked mechanism where we can precisely tell what is the difference between the arrival from the two different sides. So when we're applying this system and we are using it listening to monitors, which of course is not the primary source but a reproduction of some source, then we are using both ears most of the time. And here we have a system that is very stressed in the human auditory system. I'm showing it here on the screen. These are the two ears, the left and the right ear. And the comparison between the left and the right is actually the part of the brain that uses the most energy. So this is a really important evolutionary aspect. Otherwise, we wouldn't have put so much focus to it, of course, from an energy conservation point of view. So the red circle here shows that we are constantly using these left-right comparisons, and especially if the imaging is not natural, then that system is really working hard. And that's why it's also one of the primary causes of listener fatigue. So if we summarize the causes of listener fatigue in pro audio, the main causes are overall sound exposure, that's sound pressure level with time. But also bad imaging is extremely likely to generate listener fatigue when we're working long hours. So it exhausts this part of the brain, as I said, that uses so much energy. And finally, the third one is if we have too much high frequency energy in what we're listening to, that also IHC here means inner hair cells in the cochlea, because more of these hair cells combine for high frequency. So we are more prone to have listener fatigue driven by high frequency than by lower frequency. So many professionals use a little bit of high frequency tilt a little bit of high frequency roll-off, of course, because that enables them to work longer hours. So for instance, with the 3 dB roll-off at high frequency, we can basically double the amount of time we are listening to a certain source before we get this type of listener fatigue. But let's move on now to look at how loudspeakers work when they're in a room. In-room adjustment is very important when you have placed your speakers, and that's because loudspeakers are very different from, for instance, lamps. So if we consider a lamp, of course we expect that if we buy a light or a white light bulb, then it will shine the same color no matter where we put it in the room. It will be nice and white like this, but it's not the same with loudspeakers. So for instance, if we put the loudspeaker on the floor, it might have a blue color, so to speak, or if we put it close to one wall, it might shine greenish if we have a sound color that way. What I'm trying to say is that it depends very much on where we place this loudspeaker. So even though it has the same color from the factory, which you could call flats in an anechoic room, it will change its color depending on where we're putting it in the room. So this is why Genelec loudspeakers for decades have had dip switches to compensate for this. So you can select the proper settings with the dip switches, and that way you can compensate for the placement in the room. But for a couple of years, actually around 10 years, we have had the GLM system, which can do this even more precisely. And this is an example of many of the same loudspeakers, so they have completely the same setting from the factory, but we can clearly see that they need to be compensated very differently depending on where they're positioned in the room. So the GLM system allows us to do that. That's called the SAM monitors that can be controlled this way. Smart active monitors can be controlled by the GLM application. So how do we do it? How do we know that we have a good and static response, or a good and good response at our listening position? This has been a topic of many years of investigation from Genelec, and the most recent of this was an AES paper Aki and myself did last year for AES. You can look it up on our website. And what we basically did was to investigate how many different locations you should ideally be measuring before being convinced that your spectral response at the listening position is adequate. So this is the front page of that. So these are the listening positions here. We were systematically investigating between many different studios. I'll move on now to talk about the ones, these new point source monitors that of course have these systems built in as well. So that's how the relationship here is. So we call these ultimate point source monitors. So they are ideal in a way that they're complementary to a microphone, which typically has one capsule also. So in this case, we don't have any coloration when we're moving off axis, or we don't have coloration with head movements, because all the sound basically originates from the same center in these loudspeakers. So that means that we have, when we're working with them, that's one of the things people have been noticing with the 8351, which has been out for a while, that they can actually work longer hours before they get this type of fatigue from bad imaging. So you can also get more consistent mix decisions, because no matter how you move your head, which we're doing constantly, then they give you a good and coherent story. Extremely controlled dispersion is a big part of this. So as you'll hear in some of the other video presentations, the drivers are integrated into the waveguides, and also the low frequency dispersion or directivity is better controlled than what you would expect from the size of the loudspeaker. It can be used for ultra near field applications. So not only can you that way get a considerably higher sound pressure level, but you can also take more of the sound color out because the relative ratio between the direct sound and the reflected sound goes up. And finally, they're extremely compact three-ways, low distortion and wide bandwidth. So normally one of the very important aspects of loudspeakers is how the dispersion is into the room. And common to the ones is an extremely tight dispersion both on the horizontal and the vertical plane. We call this the horizontal plane that you're seeing here. It might look a little bit ironic, but we call the horizontal plane for the plane where you see the logo positioned correctly. So this is what we call horizontal, for instance, for the 8341. And you can see directivity going down to relatively low frequency. That's the on-axis response here. And you can see that the -3 and -6 and -9 and so forth dB here, we have extremely controlled area up to more than 30 degrees off-axis, down to very low frequency here. So in this case, below 500 Hertz. We can also you can also position them in the opposite direction. We call that vertical, and that's the one you see over here, where now, of course, the low frequency directivity is extended even further. So I have, it's great to see these, hopefully this gives you some idea of the performance, but we recently tried to find out how could we also listen to it, these differences. And it's a little bit nerdy because one of the easy ways of doing this is by playing pink noise through the loudspeakers in an anechoic room and at different angles. So I'll try to do that for you here. So if we consider here comparing now the 8331 with a classic three-way system where the drivers are at different locations, we'll start by having both of them 90-degree off-axis. So we have the microphone here, so we have a 90-degree angle and it's in an anechoic room. So I'll first play a little bit of the pink noise, the test signal. So you'll hear how the test signal sounds in your system first. And then we'll hear first the 8341 in its two orientations and then the classic system in its two orientations. So let's have a listen to that. And of course you'll hear now at 90 degrees that we have a lot of high frequency roll off, but you'll hear as we get closer to on axis that we get more and more high frequency. But we have a very recognizable pink noise sound still for these coaxials, but not necessarily for the normal three-way. So have a listen to this. We'll start by the raw pink noise here. And now the 8341, now 31, and it's a 1.6 meter distance to the microphone. And here now at 60-degree angle, we hear the same again. First the pink noise, raw electrical noise, and then the four different loudspeakers or in different orientations. You can hear the sound color of the 8331 is very consistent, and even on my small loudspeaker here on the computer I can hear that the 8331 does it better than the classic three-way. Let's move to 45-degree angle. I should note that all these examples are loudness normalized on axis, so they're all flat and loudness normalized on axis. Let's do 30 degree also, and you can hear that's the final example with noise. So I hope it's clear that the coaxial does dispersion in both directions in a very convincing way and with a very smooth response. So what we have is a system basically that is very good at imaging, it's very good at preserving transients, and it gives us fatigue-free listening. So it's really great for both when we're placing mics for the application where we need to be very precise about placing microphones. It's good for mixing and effects, and it's great for mastering, also including, for instance, deciding the width of the mix. Let's have a quick look at the SPL capability in these systems. This is the small one, the 8331, and we can see that at 1 meter it's 104 dB SPL, moving up to even 110 at 0.5 meters. And we can look at the other ones here, and we can compare that with a classic Genelec 3-way, and we can see that we're more or less on par with the sound pressure level for the distances we can use those systems with. So these are very competent 3-way systems, but of course ideal when we are at relatively close listening distance. Finally, let's talk a little bit about the source quality when we're testing loudspeakers like this, because it makes a difference. If the source is destroyed already, then you cannot expect to hear it sound wonderful out of even the best loudspeaker. And this is of course a topic I've been talking about in other under other circumstances as well. So just a few words about that. We should avoid, of course, typically in all this type of material, we should avoid lossy data reduction, because one of the first things that's sacrificed in lossy data reduction is the imaging aspect. So you cannot get good imaging back from the loudspeakers, of course, if it's destroyed in the source. There are several sources for this. You can use CD, you can use Tidal Hi-Fi, you can use iTunes if you rip your own CDs. Not if you download from Music Store, because there we still have only AAC at 256 kilobits, and you may have other linear sources yourself in a professional studio. Then you should also at least have some tracks with a decent peak to loudness ratio, because if they're hyper squashed again, there will probably be so much distortion on the track that it's difficult for the loudspeaker to do a decent job. And you could check tracks with Music Tester, which is an application where you can check the peak to loudness ratio of different tracks. Loudness normalization is a good help. So equal loudness comparisons, that's what we should always be using in the studio when we're doing not only production but also mastering. And it's also a help when you're listening to different types of music and different loudspeakers. Tidal and iTunes have this feature as well. So all in all, let's these are extremely capable loudspeakers that may not look like 3-ways, but they behave like 3-ways. And this is a photo from the brochure we can just have as the last summary of my presentation here. We have the full-size waveguide, point source principle. Can use them horizontally or vertically. They are very compact 3-ways. They are great to set up and calibrate because of the GLM application. And finally, they are produced in a sustainable way for a long life. So I really think these are some of the best, and maybe even the last loudspeakers you'll need to buy.